Section 10.1 Understanding Expectations. Weighing the unknown future. Oftentimes in life, we make decisions which we cannot completely see are right or wrong until after they are made, such as buying stock or buying life insurance. In this section, we are trying to discover how we can assess the wisdom of our decisions in real time or when we are actively trying to make them. Looking into the future, we must determine to the best of our ability the value of many possible actions we can elect to take, even while understanding that they are all gambles. We have an idea of what we seek, a measure of the value of future actions. Our strategy for developing a concept of future value is to begin with concrete examples. By focusing on situations we know we can extract essential features and then apply them to settings that are not so clear. This is done by assessing the situation in which we are decision making. We must take all factors given to us and associated with the decision into account in order to build a clearer vision of what the outcome of our gamble may be. Concrete examples. Concrete examples in decision making are external and internal factors which we can draw upon to make conclusions regarding the outcome value of our impending decision. Concrete examples are similar to hints which help guide us in the making of decisions. An instance of concrete examples could be someone on a diet who is craving chocolate cake. Their cravings are legitimate, but their diet is an internal concrete example as to why they should resist their cravings and instead opt for a healthier alternative to the cake, versus someone who is not dieting and will indulge in the chocolate cake to fulfill their cravings because of the lack of concrete examples guiding them to a healthier choice. Probability. Probability in decision making is the extent to which an outcome is possible. Many different internal and even external factors can help us in determining the probability of an outcome in a given situation. Probability is used every day in our lives, both subconsciously and consciously. Every decision we make is weighed by our conscious with probable outcomes lined up. An example of the use of probability in daily life could be trying to determine how long it will take to drive to the supermarket depending on the route. Route 1 is a straight road back to the supermarket with 2 traffic signals on the way. Route 2 is on back roads with only 1 traffic stop on the way. Which route should I take? The probability on this is tough to examine as we cannot exactly predict the traffic lights sequencing. However, it is more probable that 1 traffic light will take you less time to get through than 2, meaning that Route 2 has a higher probability of getting you there faster. Average value. The average value per decision is a measure of what we expect the outcome of the decision to be. This is our educated guess of the outcome of our decision, using what we can to analyze a particular situation. Average value uses probability in trying to make sense of the gamble we take and how to see what our outcome may be before we ever make a decision. For example, a healthy middle-aged person's decision to invest in life insurance can be justified by the probability that if they maintain their healthy lifestyle, they will get the most out of their investment. Expected value. Expected value is the average outcome of a decision we are forced or bound to make on multiple occasions. An example of average outcome would be if every 2 and 3 times Billy eats ice cream, he gets an upset stomach. Billy will now know that he is more likely than not going to get sick when he eats ice cream, due to the expected value of his decision to do so. In order to know for sure, Billy must take all the possible outcomes of his ice cream indulgence into account, positive and negative. Then he can compute the probability of each outcome and multiply the value of each outcome by its probability and add up all of the products. The sum of the probabilities multiplied by outcome values is the value on average Billy can expect from eating ice cream. Problem number 1. Someone has a weighted coin that lands heads up with a probability of 2/3 and tails up with a probability of 1/3. If the coin comes up heads, you pay $1, and if the coin comes up tails, you receive $1.50. What is the expected value of this game? Would you play? Why or why not? The solution to this problem is, suppose you get D dollars if you flip tails. The value of the game is then -5 times 2 over 3 plus D minus 5 times 1 over 3 equals D divided by 3 minus 5. Since the value of the game is 0, set D divided by 3 minus 5 equals 0 and solve for D, so that D equals $15. I would not recommend playing this game because the odds are stacked against you winning any money and in favor of you losing money instead. Problem number 2. A standard roulette table has 38 numbered slots for a small ball to land in. 36 are marked from numbers 1 through 36, with half of the 36 black and the other half red. 2 green slots are numbered 0 and 00. An allowable bet is to bet on either red or black. This bet is an even money bet, meaning if you win, you receive double what you initially bet. Many people believe red or black is fair game. What is the expected outcome of betting $1,000 on red? The solution to this problem is, the 2 green slots give the house or casino an advantage. The chance of winning on red is 18 out of 38. Therefore, the expected value or outcome is $2,000 multiplied by 18 over 38 equals 947. The expected outcome is that you will typically lose $53 betting $1,000 on red. Thank you.